Good day, ladies and gentlemen. This is Usimiledi Tologo, STEM engineer and industrial automation enthusiast. But I don't want to say enthusiast, I want to say engineer as well. So here we have our system, which I've been working on for quite some time. I'll just go over this particular part that we have here. This is my controller, and then this is my other controls, right? My controls, my start, my stop, my e-stop. I have my energizer and de-energizer, then my reset button here. I have my S7-200 PLC 226 CN. I also have my relays there. I'm not using this timer currently. And then I have my indicators, I have my contactor, and then I have this motor here, which will resemble a real life motor, right? And then I have this also what we call an inductive proximity sensor, which these are just screws. So what I wanted to do here was to be able to get feedback, right? That my motor is running or my motor is moving, right? And I'm actually able to monitor this here, because the end goal is to also create a SCADA system that will be able to monitor this. Although supported software nowadays is a problem, because this is an old PLC. Right, and I'm currently using Windows XP, which is running on a virtual machine which is hosted by Windows 10. Right, I had to do that to be able to get this to work. So this switch here will cut power to this manually, right, so that I can emulate or simulate rather like my motor not running when it's meant to be running. Okay, so let's have my system running here. I'm going to energize it. That lamp there is for the energize indicator. And then I'm going to start my system. When I start my system, my motor is running here. I'm actually monitoring right now. And then I have my status here being running, right? If I stop, my motor stops there. And then my status also goes off, right? Now, if I start my system, and then for whatever reason, either mechanical binding or problems happen there, and then my motor doesn't run, I'll do that by doing this. An alarm has to go on. There we see my alarm. Going to reset the system. I have my alarm going on, and my alarm doesn't just go on. It also the contactor is de-energized, right, to prevent an instance where we have mechanical binding at the motor, and then our coils overheat, and then a fire is created, and then a domino effect occurs where you might find a whole industry being bent because of lack of that particular protection system. So I believe this also falls under protection. This is a type of protection, right, of our motor. And then if I run, see, I try and run, but I don't get feedback that my motor is running. I also get an alarm. And then also, if my system is running the way it should be running, and then for whatever reason manually my e-stop is present, an alarm will also go on. Going to reset it. And you cannot start your system. Nothing will work until you reset your system, and the program goes over again to check if the error is still present. And then, like, if I let's say I try and put my motor in, right, it goes in, I reset, it goes in again, I try and run, it goes on. See, so that is the main idea, and this is all made straight from my head, like the logic. I wasn't following any circuit. It was all coming as I went with it. I started with a simple start stop, added an E switch, added a reset button, added a selector switch there, added my motor, added my feedback. As you can see, the screws, So it's all about being innovative and being creative as well. I believe being creative and being innovative leads to one becoming a real problem solver to real world challenges. That's all we have. That's all I have. So yeah, hopefully now I'm gonna try and see if I can use a particular OP server as well as a platform that can create a SCADA system. I'm trying to utilize free applications, and we'll see how it goes. So yeah, usimile ditolo.